inserting node at end of the doubly linked list. So the linked list is typically represented by the head or start. So here the head is represented here. The traverse the list till the end, because here I want to insert my new node at end of the list. So whenever we are taking the linked list, which it the linked list head pointer will denote the first node of the list. So we have to move our pointer cursor to end of the node by step by step. So for that we have to make the temporary temporary node variable to move the cursor into the end of the list. Then we have to break this two links and establish the link. This establish four links. So we should modify at four locations. We will see that one by one. Here I am having initially I am having the head is null. So here I am checking my head is null, that means my list is empty. My list is empty. Then tail also null, tail also null. So if it is the case, when I am inserting the new node, so new node, here I am passing the value 10, value 10. Now I am creating the node. I am creating the node with variable new node. Okay, in the variable new node, then this is the new node which is having the memory location 500. Then next field also null, previous field also null. This is the previous, this is next. The data is 10, data is 10. Now what we want to do, we are checking, right? Head equal to null, yes, head is null, head is null. So that means my list is empty. So if my list is empty, my new node will become the first node in the list, first and last node in the list. Our aim is inserting the node at the end, but list is not having any node. So the node which is going to be inserting as a last node and also first node of the list. So the what we have to do, so head pointer has to be written. So head will denote the new node. So 500 will overwriting instead of null, instead of null. Then also tail also now denoting the same node, tail also denoting the same node. So here also 500 will be written. So this is what these two statements. Now my node is inserted into the list. But now we assume we are having, right, we are having n number of nodes in my doubly linked list, n number of nodes in my doubly linked list. So here I am having three nodes. So this is 101, 102, 103. Then this is null, next field is null, previous field of the first node also null. Here head pointer is 101, so which is denoting the first node. Tail pointer which is 103, this is denoting the last node. Then first node is representing the second node, so link is created. Then 102 is representing the next node 103, then link is created. Likewise the previous field of second node is denoting the first node, so 101 is represented here. The third node is representing the second node 102, so the backward direction link is created. Now here I want to insert my new node. I am creating the new node with the value of 10. Value of 10. So now I am creating the new node which is the 10. Next field also null. Previous field also null. Address will be 500. Address will be 500. So now my mouse pointer is at the position of head node, because in the linked list always the pointer will denote the first node of the list. So head pointer denoting the first node. So my pointer is available here. So what I'm what I want to do, I have to move step by step into the last node to insert the new node into the end of the list, at the end of the list. So for moving step by step, I am creating one variable in the name of last, in the variable name of last. Then for the last, I am assigning the value head. What is the value of head? 101. So the last is denoting the first node. Okay, head node, right? This is the head node, right? So now this head node, the last node value is what is the last dot next? Last dot next is 102. So 102 is not equal to null. We are checking, right? We are checking the field of next, address field of next. So this is 102 in the iteration number 1. In the iteration number 1, the last dot next is 102, not equal to null, not equal to null. This condition is true, this condition is true. So if it is true, we are making last dot next is assigned to last. What is the last dot next? Last dot next is 102. So 102 is assigned as last. Previously last is 101. Previously last is 101. Now 102 is assigned to the last. So this last variable is updated with 102. So now this is becoming the last. So last variable is having now the second node in the list. Again, iteration number 2. So one not last dot next. So now the last dot next is 103. 103. So 103 not equal to null. Yes, it is true. Since it is true, this statement is executed, that last dot next. So now last dot next is 103. So 103 is assigned to the variable last, the variable last. So now this last variable is updated with the value 103. So now this is becoming the last node, right? Then again we are going back to the while loop. So in the iteration number 3, right, last dot next, last dot next is this field. Okay, this field is null, this field is null. So last dot x is null. So null not equal to null. So which is becoming the false. If it is becoming the false, then the execution will come out of the while loop. This will come out of the while loop. So now the last pointer is denoting the end node of the doubly linked list. So now the last dot next is updated with new node. The new node address is 500. So last dot next is updated with 500. So here the 500 is written on the next field of last node, next field of last node. Then now what is the new node dot previous? So new node dot previous will be written as 103. So 103 available in the variable last, right? So new node dot previous is written as last. Okay, so now the link is created. Then finally, which is the tail node? Tail node will become the new node. So the tail node is updating with new node. So address will be overwriting as 500 in the tail pointer, in the tail pointer. So that's what written here. So now last will be, so the last is updated, last is updated with new node. Okay, new node. So this is updated with new node 500. So this is the procedure to update the node at end of the doubly linked list. Thank you.